In this activity, we're going to take a look at the probability that an event will not occur. Let's take a look at question number 1. A report by Esurance found that 77% of drivers have been in at least one accident. Assuming this is accurate, if a random person is asked if they have ever been in a car accident, the probability they answer yes is 77%. What's the probability they answer no? Well, I think you've probably got a good intuition for this problem, but let's just think about why a little bit. If 77% of drivers have been in at least one accident, then we would have to do 100% minus 77%, which is 23%, to find the number of drivers that have not been in at least one accident, which means none, right? Which would not be me. So what's the probability they answer no? That's going to be 23%. All right, why don't you pause the video, take a look at number 2, answer it, and start the video when you're done. So this problem says if you go on a 1,000-mile trip, your probability of getting in an accident is about 1 in 366. So roughly that would mean if you did this 366 times, you might get in one accident. Or if we looked at, maybe a better way to say it is, if we looked at 366 people that went on a 1,000-mile trip, we would expect one of them to get into an accident. So we would expect how many to not get in an accident? Well, that would be 365 out of 366 not in an accident. Now, another way to think of this would be to think about this number as a percent. Then if we thought of this is not a very nice percent, but we would take 100% minus this percent. So if we don't write it as a percent, we could write it as 1. 100% is 1, written as a decimal number, minus 1 over 366, and that's going to give us this number right here. All right, I don't know if I said that as nicely as possible, but if you think of this 1, if you write that as a percent, that's 100%. And whatever percent this is, we would subtract that percent, just like we did up here. We would subtract whatever percent this is, just like we did up here with the 77%. We subtracted that from 100%. Well, if we had this 77% number as some kind of a fraction, 77% is 77 out of 100, which doesn't reduce, but we could take 1 minus 77 out of 100, and that would give us 23 out of 100. Which is 23%. So that's all I'm saying down here with the 1. All right, so this idea of something not happening has a name, and that's called the complement, the probability of something not happening. My formatting didn't quite work here on this PowerPoint, but in your notes it should look like there's a line above this E. So P of E is the probability that E occurs. The notation PE with a bar over it represents the probability E does not occur. So E with a bar over it is called the complement of E. All right, so let's complete this table. If the probability something happens is 10%, what's the probability that it doesn't happen? That's what this means over here. What's the probability that E doesn't happen? Got it? Yeah, that's going to be 100% minus 10%, or 90%. All right, why don't you pause the video, complete this table, and start it up when you're ready. All right, how'd you do on those? 90%, 50%, 30%, 0%, 100%. Now, this last one, n%, you need to think about how you got all these other answers. How did you get all these other answers? Well, you subtracted 100% minus the probability that the event did occur. So in this case, the probability that the event did occur is n%. So this is literally the answer to that question. You can't really simplify that. The probability that E does not occur the probability that E does not occur is 100% minus n%, where n% is the probability that E does occur. All right, so let's look at one more example down here. What is the probability of not rolling doubles with two 6-sided dice? All right, pause the video, take a shot at that one. Well, let's think of this two different ways, all right? Let's use our complement. So the probability of not rolling doubles is going to be 100% minus the probability of rolling doubles. So do you remember the probability of rolling doubles? We might have to go back and look at this chart up here. We've got our dice, rolling doubles with two dice, which happens right here. 1, 2, 3, 4, 5, 6. All right, we've got 6 ways out of 36 for rolling doubles. So the probability of rolling doubles is 6 out of 36, which reduces down to what? 1/6. So 100% minus. Now I'm writing the probability of rolling doubles as a fraction instead of a percent. So because of that, instead of writing 100%, I'm going to write 1. All right, so 6 out of 36 reduces down to 1/6, and 1 take away 1/6 is 5/6. So that's my answer. Or you could have changed the 1/6 into a percent, but it's not a very nice percent, so I wanted to go with fractions. So that's the probability of not rolling doubles. Now let's look at one more way we could have done this. And I'm just going to go ahead and write it up here. So the probability of not rolling doubles is the number of ways that are not doubles, the number of rolls that don't come out to be doubles, divided by the number of outcomes. So how many of these are not doubles? Well, we have 36 of them here, and we can see 6 of them are doubles. So all the rest of these guys are not doubles, right? All of these. How many are those? All of these guys here are not doubles. All of these guys. 36 take away 6, right? So there's 30 of them that are not doubles out of 36. And that reduces down to 5/6. So you could do it either way. You could do the complement and subtract it from 1. You know, subtract it, the probability of getting doubles from 1 or from 100%. Or you could count the number of ways of not getting doubles.